Welcome listeners again to our next topic of discussion, that is on economic geology and processes. So again, this is in the series of our discussion on fundamentals of geology, and on this topic mainly we will be looking at the various economic processes, mainly to look at the deposition, that how mineral deposits form. But apart from your coal and petroleum, we will not be looking into coal and petroleum in this particular lecture, but in the subsequent lectures we will be dealing with the processes of formation of coal, definitely how they form, and obviously what are the other aspects when we are dealing with coal, and same as for your petroleum. So they will be discussed in the subsequent lectures. So in the first part of economic geology, to start with, obviously economic mineral deposits are extremely essential for our society, as well as our daily life and livelihood, as well as for the industrial and infrastructural development across the globe. So your ore deposits are naturally occurring concentrations of minerals or metals. So you can see that obviously whatever metal you are using, be it iron, copper, zinc, lead, whatever you are using, are being extracted from some rocks. So your ore deposits are naturally occurring concentrations of minerals or metals that can be economically extracted for profit as well as for utilization. So your profitable extraction, if a mineral deposit is having, for example, some lead in it, but it is not of extractable quality, or to extract that lead from that particular deposit, you need to spend a lot of money. So in that case, it will be not considered at that stage as an economic deposit. Rather, if I am saying that a rock or a horizon is economically beneficial, then only I will be considering the mineral deposits associated with that as economic mineral deposit. There are numerous types of ore deposits, and each have been formed with respect to certain geological processes. So why we need the classification of economic mineral deposit? Because to actually segregate different kinds of minerals, for example, when you, like in the beginning I segregated that coal and petroleum will be discussed in our subsequent discussion. So here we are mainly looking for, mainly you can say metal, a few non-metal deposits. Apart from that, you need to have a very clear idea that which are the host rock, or which are the processes, geological processes, that will deposit a specific kind of a metal, for example. So your ore deposit classification recognizes the different geological processes that are involved in the formation of a deposit, but mineral deposits may vary widely in metal content, form and economic value as well. So the classification helps us to organize these diverse attributes of this analysis. It aids in the understanding of geological context and economic potential, and the classification enables us for making a comparison and correlation between the different deposit types. The main goal is to optimize mineral resource exploration and utilization. So several kind of classification schemes are available, but here we'll study the most accepted or widely used scheme of classification of mineral deposit based on their mode of occurrence, that how it is occurring, and which are the processes that are related with a specific kind of a mineral deposit, or a geological process that might lead to the accumulation of a specific kind of a metal in some rock, or even some cases non-metal minerals as well in some rock. So the most widely accepted one is the Bateman's classification, that is mainly based on the genesis of the mineral deposit. So here, just to start with, I can look at this rock layer, very beautiful bandings you can see of magnetite, hematite and chert, which is obviously your silica. And you can also look at these chromite layers from which you can extract chromium whenever and you kind of means an excavation is going on. So these are the zones where at the mining engineers will target for excavation of these economic mineral deposits. So, starting with the several processes based on the genesis of the mineral deposit, the first one is the magmatic processes that are completely related with some kind of magmatic activity deep within the earth or on the surface of the earth, and they are generally governed by high temperature and pressure. Type of this magmatic deposit or magmatic processes include early magmatic deposit, also late magmatic deposit that have been formed at a later stage of your magmatic differentiation process. So, the early magmatic processes include disseminated crystallization of, for example, kimberlite pipes. Kimberlite is definitely an igneous rock, and that bears signatures or presence of that bears diamonds. So, diamond deposits are a type of disseminated crystallization. When we are talking about chromite layers, then we are looking at actually segregated chromite deposits. Then some deposits can also formed as a result of magmatic injection, that some molten material has been injected to, for example, in a fault zone or in simply along a joint surface. There also, due to this kind of injection, your magnetite deposits can form like this. Also, by injection into any kind of void space, if some molten material is getting injected, then you can also get this kind of injection related magmatic deposits such as magnetite. In the late magmatic processes, however, these are, you can say, these are the residual liquid after the solidification of a rock. Some residual liquids bear sometimes some metal, sometimes some non-metal deposits along with it. So, this role of this residual melt is to solidify to a place where it can obviously crystallize, and some like I was mentioning, some space is being created somewhere by a bit due to simple some kind of discontinuity in the rock layers, or due to some induced discontinuity like faults or joints. So, your residual liquid segregation is a type of late magmatic process which deposits magnetite. Residual liquid injections also can lead to the deposition of magnetites and pegmatites. Then immiscible liquid segregation that mainly deposits your platinum group of minerals, and sulfide deposits they are. An immiscible liquid injection may lead to the deposition of gold sometimes again platinum group of minerals like this one. Then you have the second process, that is the process of sublimation, where it is generally low temperature pressure condition related to some kind of, again for example, some molten material is present underneath, and then it is going into your process of the sublimation. So, it will result into the outpouring of the metal or non-metal deposit that is present just beneath the surface. So, there you can have some outpouring of sulfur like this. So, this is an example of sulfur deposits from Mount Io in Japan. Then comes the deposits related to metamorphism. The first one is your contact metamorphic deposit. We discussed about contact metamorphism when we discussed about metamorphism as a whole, or the metamorphic rock specifically. So, there if you can remember, then if there is a set of again sedimentary horizons, and in that molten igneous rock is intruding and then solidifying, then in the process of its solidification, what will happen, it will try to melt the margin in contact with the sedimentary rock. So, this zone of your or this margin surrounding the intrusive igneous body is referred to as your contact aureole, like we have discussed, and there is continuously both temperature and fluid exchange between the intrusive igneous body between this contact aureole as well as the sedimentary sequence. So this kind of contact metasomatic deposit, the examples are magnetite, copper and gold at times. So you can also look at this diagram again. So these are some hydrothermal veins, the veins that are getting injected into the sedimentary horizon from this intrusive igneous rock. So again there will be chemical exchange also between the intrusive igneous rock, the contact aureole, and partially also with the sedimentary sequence. Here it is a sandstone, shale, limestone sequence like this. So your magnetite, copper and gold can also form in case of a contact metamorphic deposit or as a result of contact metamorphism. Then this is very important one, the hydrothermal processes which are of low to high temperature, pressure conditions, they might occur, and they are grouped into certain subcategories, that is telethermal, epithermal, leptothermal, mesothermal, hypothermal and xenothermal, based on the pressure and temperature regime. So hydrothermal processes are nothing but, like we have just seen in the earlier one, that if these hydrothermal veins are getting injected from the source is obviously the melt source, or the hydrothermal source is nothing but this igneous rock here. So now you have a high temperature chemically active fluid, like we discussed in our discussion in metamorphism. So this high temperature chemically active fluid will now get injected as your hydrothermal veins, leading to the formation of, then after injection definitely it will be solidified at some point of time, and these hydrothermal veins are generally these kind of veins evolve at the later stage of the crystallization of a massive igneous rock, like we have seen in the earlier diagram. So these hydrothermal veins always they contain this residual liquid, and obviously those minerals or metals which don't have an affinity to crystallize along with the rest of the molten magma. So that's why I'll now not go into the idea of compatible and incompatible elements, but that is at advanced, means that requires an advanced understanding of the subject. But just to cite here that the metals or minerals that are getting solidified with the igneous rock can be considered as compatible to it, and those which are not being able to solidified with the igneous rock are simply injected through the hydrothermal veins that are later on getting injected into the host rock. So based on temperature and pressure conditions, these hydrothermal processes are grouped as telethermal, again epithermal, mesothermal, hypothermal, xenothermal. So this graph simply or chart shows you that how at very low pressure condition you have telethermal processes, near surface processes like lead, and these near surface hydrothermal processes will prompt the presence of your lead zinc deposits, like we get to see near the Mississippi River. Then at subsequently higher relatively higher pressure but still low temperature between 50 to 200 degrees centigrade, but relatively higher pressure than that of the lead zinc deposit of Mississippi, you have between 0 to 1500 meter you have epithermal deposits. So these are, you can say, antimony deposits of Kashmir. Then you have this temperature range of between 200 to 300 degrees centigrade with a pressure low to moderate pressure. In that case you will get a kind of deposit that will be grouped or categorized as mesothermal hydrothermal deposit between a depth of 1200 to 4500 meters. Again a very good Indian example is the lead zinc and copper deposits of Java, Rajasthan. Then you have very high temperature hydrothermal deposits such as between your 300 and 600 degrees centigrade. The xenothermal and hypothermal, the only difference between the xenothermal and hypothermal hydrothermal deposit is a function of your pressure. So when the pressure is low but the temperature is high, you will get xenothermal shallow deposits like your SN and AG means silver and tin deposits of South Bolivia. When you are looking at the hypothermal deposits at again a very high temperature, but here it is high pressure as well. So it occurs beneath a depth of approximately 1.5 to 3 kilometers, and the characteristic type of deposit you will get in case of hypothermal is your gold deposits, again the color gold fields of India. Then talking about the deposition patterns, so this hydrothermal processes like telethermal, epithermal, mesothermal, hypothermal or xenothermal processes, these are the processes that will operate within this temperature pressure range. A very wide variety can be found, but then obviously that mineral or metal will be subsequently deposited. So the type of deposit it will form, the first one is the cavity filling, like this, the cavity filling of gold here you can see like this. So here there are examples like fissure veins that are characteristic of gold and silver. Then shear zone deposits also, because their shear zones are zones of obviously weakness, like that of fault, and definitely there will be some displacement and some space that will get created. So there is a tendency of hydrothermal melts to simply utilize these zones of weakness. So your shear zone deposits such as gold and silver can be found also as stockworks, ladder veins, saddle reefs and tension crack fillings like lead and zinc. So most of these hydrothermal deposits which occur as cavity fillings are very favorable, and you can say good candidates for means in search of gold and silver. Then you can also have breccia fillings, then solution cavity fillings, pore space filling and vesicular filling. So for breccia fillings, it could be a result of a volcanic eruption, it could be result of a fault or due to some collapse structure. So this kind of breccia fillings you will get gold, silver. In case of tectonic breccia you will get zinc. In case of collapsed breccia you will get copper or sometimes gold as well. In case of solution cavity fillings, you can have caves and channels that will form and through which your solution will percolate, and some gas veins as well. So your caves and channels include deposits of lead and zinc. Pore space fillings are mainly you will find copper as your pore space filling. For vesicular fillings you will also get copper as a mineral deposit. Obviously it's a metal deposit. In case of apart from this cavity fillings, you have a type of replacement hydrothermal deposit, massive lode fissure or disseminated type. So an example of a massive hydrothermal replacement deposit will be your copper. In case of lode fissure kind of replacement hydrothermal deposit will get gold. In case of disseminated nature of the replacement hydrothermal deposit formed as a process of replacement, you will get copper. So this is an example of how this hydrothermal material kind of forming a stalk like pattern with dikes that are simply cross cutting the host rock, and there is some porphyry ore of copper that is present. So your polymetallic replacement deposit showing the distribution of ore types and host rock. So these are the host rock, and obviously as there is some limestone present in contact with this or from the heat supplied from this, for example, igneous body to the limestone, this limestone will form a skarn type of deposit which are characteristic of contact metamorphism of limestone. And apart from that you can also think of replacement ores like this. So these are the various kinds of replacement ores. Now coming into the types of deposit formed simply by the process of simply by sedimentary processes under sedimentation event in low temperature pressure condition. So the type of deposit will be obviously sedimentary, like we get to see in magnetite, hematite and chart, and also sometimes in case of manganese and phosphate. Your bacteriogenic means obviously some biological processes are involved in this. So these are mainly bacterial products or found by the reduction of certain minerals. So an example is the sulfur in salt domes or manganese nodules that we will find in the deep sea ocean floors. So they are related with your bacteriogenic activities. Then the seventh type is your submarine exhalative volcanism. It happens in low to high temperature and pressure condition. So you can think of the submarine volcanism. These are mainly gaseous in nature. That's why they are also referred to as black smokers. So your black smokers are your submarine smokers are very very characteristic of your mid-oceanic ridges. So in case of submarine volcanic activities, that usually obviously takes place along the mid-oceanic ridges, along on the trend of the mid-oceanic ridges. So the examples include manganese nodules and some polymetallic sulfides as well. So this is strictly related to volcanism, but remember it is submarine in nature, that the volcano like that, not of a continental arc scenario, it is a volcano exactly or always related to the mid-oceanic ridges. So you can definitely have your ocean floor basalt that is getting outpoured on the surface of the ocean floor along this or across these mid-oceanic ridges. So these mid-oceanic ridges are your sites for your submarine smokers, or what nowadays referred to as the black smokers, because of the gas emanating out from these zones. Then some deposits can also form by the simple process of evaporation, like we discussed the process of formation of Sabkha deposit in our discussion with sedimentary rocks, where you will get the deposit will be evaporite in nature, mainly halides will be present, sometimes gypsum and some other carbonates are also present in this case of evaporite deposits. So mainly marine evaporites include deposition of gypsum, salt, potash. Lake evaporites will generally give you sodium chloride, and groundwater will give you mainly chili nitrates. So these are the different types of your evaporite deposits strictly formed by the process of evaporation. Then you have also some deposit related to the residual concentration of minerals. So your residual deposits example includes iron, manganese and bauxite. And mechanical concentration, these are again one of the best example, that if again we discussed about different erosional feature of streams, then wind, then glacier, and these are the different kinds of, you can say, means erosional features that are associated with these agents of erosion. They can also lead to formation of a kind of deposit referred to as the placer deposit. Placer deposits are nothing but deposit formed by the action of erosion from, for example, I will give you an example and it will be easier to appreciate this kind of deposit, that if somewhere there is a gold lode that is present, but you do not know the real location of that gold lode, but there is a stream that is simply cutting across that region. So downstream of that region you might get smaller sized or particles of gold. So in that case you will be categorizing this kind of placer deposit as your stream placer, sometimes as your alluvial placer, sometimes as your beach placer. So it depends on which kind of placer you are dealing with, but examples include your gold, tin and also sometimes thorium in case of your beach placer. In the beaches of Kerala, there are several beaches where you will get high amount of thorium contained in the beach soil. So that is also a kind of a beach placer, that the thorium is coming from some nearby region. So then the 10th type of your process that will lead to the formation of economic mineral deposit is the surfacial oxidation and supergene enrichment. So this diagram actually showcases this kind of processes where under rainfall there will be a zone of Gaussian, then followed by the zone of least zone where your rain can percolate. Obviously these zones will be of high chemical weathering, leading to what leading to a zone that is oxide. Finally an enrichment zone will come where you can get mineral deposit like that of copper that you will get under oxidized supergene sulfide. So your enrichment zone will give you your copper sulfate like substance, and they are obviously of high economic value. Then again comes the metamorphism, the types of metamorphism related to their temperature and pressure. So here we are only looking at your intermediate to high temperature and pressure, not temperature only. If only temperature is involved, then that is considered under contact metamorphism. Here we are dealing with high temperature, pressure both. So metamorphous deposits like copper, lead, zinc can form. Also other metamorphic deposits include presence of graphite, asbestos, talc, soapstone, sillimanite and garnet. So garnets are also used as a specific category of gemstones. So they these mineral deposits sometimes may become, apart from gold, silver, platinum, apart from these ornaments also, for gemstone purposes also these various forms of these mineral deposits are used. Like that we have given an example of garnet. Then finally concluding about the geological processes, these 11 you can say the mineral deposits are categorized into these 11 types. So apart from that I will be only discussing a little bit about the uranium deposit, because they are obviously the nuclear fuel that we will get from uranium. So that because uraniums are radioactive in nature, so obviously the types of radioactive minerals will include both primary minerals and secondary minerals. So the primary minerals are those formed directly from magma, hydrothermal solution and groundwater like uraninite. Then you have secondary minerals that are formed due to remobilization of elements from primary minerals, their transportation in solution and later precipitation due to oversaturation in an oxidizing or supergene environment, like the presence of thorium that happens in supergene environment. So thoriumite is a secondary mineral that bears thorium, and that is also radioactive in nature. So these are the two types of your uranium bearing or thorium bearing mineral deposit. Major types of uranium deposits also can form through hydrothermal vein type activity. It can be hosted by sandstone. It can be present along your unconformity zones, strata bound carbonate hosted type, and other types include faults and shear zones as well. Like one of the biggest uranium deposit that we get is in the Shingbhum province of Jharkhand, and there is a large scale shear zone of more than 200 kilometers, that is the Shingbhum shear zone. There you will find along the shear zone there are distinct occurrences of uranium. So that's why they are grouped under this Shingbhum thrust belt in Jharkhand, and these are the running mines: Jadugora, Bhati, Narwa Pahad, Turamdi. These are the running mines from where your uraniums are being extracted. So that's a part of the Shingbhum uranium province. Apart from that, you have the Mahadek uranium province that is present in the Meghalaya, and Kadapa uranium province that is part of Andhra Pradesh, and there are smaller deposits in Aravali and Bhima basin in Karnataka as well. So these are the uranium reserves in India, and that obviously serve as the main you can say nuclear fuel that runs a nuclear reactor to generate electricity. So the other two fuels, obviously they are not like that of uranium. We will be discussing in the next two lecture. One is about coal and petroleum, and the second one will be about petroleum. Both are your fossil fuels. So here I would like to end my first part of discussion on economic deposits, or then we will be looking at the fossil fuels. Thank you.